All right, in this video we're going to talk about intervals and inequalities and interval notation. So what an interval is, it's a set including all real numbers in between two endpoints. So it could be like all the numbers in between 3 and 5 or something like that. Right? Graphically what it represents is a line segment on the number line. Right? That includes all those numbers that line segment covers. All right. Inequalities are used a lot of times, or intervals are used when we're solving inequalities. They're used when we're talking about the domain and range of a function. And there's other applications as well in mathematics where we talk about the interval or intervals between two numbers. All right, so when you're dealing with intervals and interval notation, the notation that you see is very important. Right? It's one of those things where I've said before, and I'll probably say it another 100 times before I'm done doing all these videos. In mathematics, the notation is very important. The symbols that are used mean something specific, and if the symbols are a little bit different, then it means something a little bit different. Right? As you can see here, all these things listed on the left, they all look pretty similar, but none of them are the exact same thing. All four of these mean something completely different. All right, so the first one here, for intervals, again, for A, comma, B, those represent two numbers on the number line. So let me put one up here that actually has some numbers in it, so hopefully it makes a little more sense. So like I said before, if we have 3, comma 5 in parentheses, right, what that represents is all the numbers on the number line in between 3 and 5, but not including 3 and 5. Right, so it can be 3.00001, 4, 3.2, 4 3/4, 4.99999, right? Every number in between 3 and 5 is included in that interval, right? So that's what we mean here. So the A and the B, those usually represent numbers. This is what we call the interval notation. The interval notation is the one that has the parentheses and the brackets. The one in the middle here is what we call the set builder notation. It's the set of all x such that A is less than x is less than B. Right, so x can be any number in between A and B, but notice less than A, or A is less than x is less than B, not less than or equal to. Right, so that's telling us that those endpoints, the A and B, or the 3 and 5 in this case, are not included in that interval. All right, and on the number line, as we see here, right, we have the A and the B, or the 3 and the 5, and the open circles means that those endpoints, the 3 and the 5, are not included. Right, so when we're talking about the notation that we use for intervals and inequalities, the parentheses correspond to the less than symbols, correspond to those open circles on the number line. All right, the next one here with the brackets, A, comma, B, surrounded by brackets, that means the set of all x values such that A is less than or equal to x is less than or equal to B. Right, so when you have the brackets there, that means we do include those endpoints. Right, so if I had 3, comma 5 as my interval, it's almost the same interval, it's almost the same set of numbers, only the one with the brackets includes the 3 and the 5. Right, remember, the one up here with the parentheses, the 3 and the 5 are not included, which on the number line we represent with that open circle. With the brackets here, the 3 and the 5 are included, which on the number line we use a filled in or a closed circle. Right, so again, the parentheses refer to the less than symbol, refer to the open circle on the graph. The brackets refer to the less than or equal to symbol, refer to the filled in circles on the graph. Right, so again, when we're talking about intervals, sometimes we include the endpoints, sometimes we don't. It depends on the application we're doing and whether or not we need to include those numbers or whether or not we're even allowed to include those numbers. All right, so again, the notation is important. Right, the parentheses means I don't include the 3, I don't include the 5. The brackets means that those 3 and those 5, or the 3 and the 5, are included in this set of numbers. All right, so again, paying attention to the little details, and we can also have some combination. We can have bracket A, comma B, parentheses. Right, the bracket next to the A means that the A is included. The parentheses next to the B means that the B is not included. Right, so we can have one endpoint included and the other one not included in our set. Right, so here's the set of all x such that A is less than or equal to x is less than B. Right, so x can equal A, but it's just less than B. It cannot equal B. Right, so the A has the filled in circle, the B has the open circle. And we can also have it the other way, parentheses A, comma B, bracket. Right, so in this case, the A has the parentheses, which means the A is not included. The B has the bracket. That means the B is included. right? So you can have one endpoint or the other included or not included, or both included or both not included, right? So again, when you're dealing with intervals and you're dealing with, again, a whole set of numbers in between two endpoints, it includes everything in between 3 and 5. The only question is, does it include the 3 and the 5 or one or the other? And that's where this notation with the bracket and the parenthesis, it becomes really important. So you really have to pay attention to, do I have a bracket there, do I have a parenthesis there? Or you have to write the notation yourself. You have to decide, do I put a bracket on the 3 or do I put a parenthesis there? What about the 5, a bracket or a parenthesis, right? So it's things to consider as you're working with intervals and inequalities, right? I'm going to pause the video here and put up some other intervals, ones that involve infinity. All right, so what we have up here now are what we call one-sided inequalities, or intervals that involve positive or negative infinity. All right, and I don't think I mentioned this in the last set that I had up here, but when you're doing the interval notation, the smaller number is always on the left and the bigger number is always on the right. They always go in order. So if you're looking at the number line, right, the smaller numbers on the left side, the bigger numbers are to the right. The numbers in your interval notation follow that same order as they do on the number line. Smaller on the left, bigger on the right. Okay, it's a common mistake I sometimes see people make is just to put them out of order, but it always goes in order from lowest to smallest, or sorry, from lowest to biggest. All right, so here the interval from a to infinity with parentheses around each one. That is the set of all x values such that a is less than x. Right, so from a to infinity, basically is what we're saying is we're starting at the number a, whatever that number happens to be, and then that interval is going all the way off to the right, all the way down the number line towards infinity. Right, so it includes from that starting point a, and then off to the right, the entire rest of the number line is included in that interval. Right, it's all numbers where x is, or when a is less than x, or where x is bigger than a. Right. The next one here, bracket a comma infinity. Right, that's the set of all x values such that a is less than or equal to x. Right, so same idea, it's just that now that the a has the bracket next to it, and a has a less than or equal to sign, now we're including that endpoint a in our interval. So it's all numbers starting at a, including a, and then going to the right off towards infinity. Right, whereas this one up here, with the parentheses on the a, doesn't include that starting point, doesn't include that endpoint. It's just all the numbers to the right of that point. Right, and then on the other side, we have negative infinity comma b. Right, that's the set of all x values such that x is less than b. Right, so it's kind of like starting at negative infinity, so starting all the way off on the left of the number line, and it goes all the way up to that number b, but since it's x is less than b, and since b has that parentheses there, that b is not included in that interval. Right, so it's everything on the number line, but stopping right before you get to b. Right, and then negative infinity comma b with the bracket, same idea, except now the b is included, so it's the set of all x such that x is less than or equal to b, so it's everything from negative infinity all the way on the left of the number line up to b, and including the b. So now that b that has that filled in circle, that closed circle, because that number is included in this set. Right, and notice for all of these, the a or the b could have the bracket or the parentheses depending on whether or not you include that number. The positive infinity and the negative infinity always gets the parentheses when you're doing the interval notation, because remember, infinity or negative infinity, those are not actual real numbers. Right, there is no number infinity. Infinity is just the concept of something that goes on forever. If I keep on going down that number line forever and ever and ever, I never actually reach infinity. I just keep approaching infinity. I'm going towards infinity. I never actually get there. Right? No matter what huge number you get to, no matter how far you go down the number line, it still continues on forever past that point. Right? So you can never actually reach positive or negative infinity to include them in your interval, and so we never include them in the interval. They never get the bracket, they always get the parentheses. All right, the last one up here, negative infinity comma infinity. Right, both parentheses, like I just said, you can never include those, so it gets the parentheses. This represents the set of all real numbers, which you can say all real numbers in words, or we can use this notation here, which is like a capital R, but with like a double vertical line on the left side. All right, so that's the set of all real numbers, which means every single number on the number line. Right, negative infinity to infinity means we include every single real number that's out there is included in this set. All right, so these are what we call, again, the one-sided inequalities, the intervals that involve infinity, or we can have the intervals like we saw a few minutes ago in between two real numbers. All right, so those are intervals and inequalities. I'm going to pause this here and then put up a couple examples for us to look at, kind of getting used to this notation. All right, so I got a few examples up here of taking things that are in the inequality notation, and we're going to write them in the interval notation with the parentheses and the brackets. And I put up here just some basic guidelines of how to do this. So when you see the parentheses, whether it's the left side or the right side parentheses, those correspond to the less than symbol in the inequality, which corresponds to that open circle when you're graphing something on the number line. And when you have the brackets on either the left or the right side, that corresponds to the less than or equal to symbol in the inequality, which corresponds to the closed circle or the filled in circle when you're graphing it on the number line. All right, so if you can get those things straight as far as which symbols correspond with which ones, doing the interval notation is not that difficult once you get the symbols under your belt. All right, so -1 is less than or equal to x is less than 2, and I want to write that in interval notation. Right, again, when it says interval notation, that's the one with the parentheses and brackets. All right, parentheses or brackets. All right, that's what we mean by interval notation, right? And I make that note because when I've taught classes before and I've given students problems to say, write this in interval notation, people will write it as an inequality. That's not interval notation, right? That's inequality notation. Interval notation is the one with the parentheses and brackets. So read problems carefully, give the answers in the form that you're asked to give them in, depending on which book you use in your math class. Some of them might not care, it might not specify. Some will say, give your answer as an inequality. Others might say, give your answer in interval notation. Right? If you don't put your answer in the right notation, you don't have the right answer. Right? So again, read the directions carefully. Make sure you understand which terminology we're talking about. Intervals are the parentheses and brackets. Inequalities are the ones with the less than or equal to symbols. All right, so -1 is less than or equal to x is less than 2. Well, -1 here, since -1 has that less than or equal to sign with it, that means that -1 is included in this interval, which means when I go to interval notation, I use that square bracket. Right, so bracket -1, comma, and then x is less than 2. Right, so 2 is my right endpoint, and since x is just less than 2, that means 2 is not included, which means 2 gets the parentheses. All right, so it's bracket -1, comma 2, parentheses. All right, I hope that makes sense. Again, less than or equal to corresponds to, with that equal to sign there, when that number is included, it's a square bracket. When it's just a less than symbol, that number is not included, it's the curved parentheses. All right, and basically when we're going from an inequality to interval notation, we're taking the same numbers here. The numbers are not going to change. Right, so it's still a -1, comma 2. We just take out that x in the middle, we take out the inequality symbols, and the parentheses and the brackets correspond to which of those inequalities we have, the less than or equal to. All right, some people are probably thinking, well, if we already have this inequality notation and we have this one that means the exact same thing, why do we have two different notations for the exact same thing? My best answer for you is mathematicians like things to be as concise as possible. They like to use as few symbols as possible when they're writing things down. So these less than or equal to's and this x in the middle, that's just too much for them. So they just take the numbers and put a bracket in the parentheses just to make it a little bit more concise. And so we have these two different notations we have to deal with. All right, lucky for us. All right, 1.5 is less than or equal to x. It's less than or equal to 4. All right, so for that one, since both of these are included, right, they both have the less than or equal to, that means both the 1.5 and the 4 are included, which means they both get square brackets. Right, if you're doing these problems on paper, when you write down your answers, make it clear whether or not you've got a parentheses or a bracket there. I've seen also students in the past do stuff like this, where I'm like, that's kind of looks like a bracket, but it also looks a little bit like a parentheses, and it's kind of hard to tell. So make sure you make it clear whether you have a square bracket or a curved parentheses. It's one of those things I don't always teach you sometimes. All right, the last one here, -3 is less than x. This one I'm going to put on the number line. If -3 is less than x, that means x is bigger than -3, which means it's going off in that direction. So my interval is going to be starting at -3 with a parentheses, right, because it's just less than x, so it's not included. And then it's going off to the right, and there's no right endpoint here, which means it's going off towards infinity. Right? And remember, the infinities, the positive and the negative infinities, always gets the curved parentheses, never the square bracket. So this is the interval notation that corresponds to -3 is less than x. All right? So that's interval notation inequalities. It is something that will pop up again and again throughout your mathematical journeys. So it's important to understand what that notation means from the start.